Welcome back. I've had some last minute requests to make some videos that students want help with. So this video is going to be about the CPU. CPU does one main job, which is to carry out the fetch-decode-execute cycle. It fetches instructions from memory, decodes it, and executes it. Every time it fetches the instruction, the program counter is incremented to point to the next address that needs to be fetched or written to. And then the MAR holds that address temporarily, pointing towards that address. And the MDR holds data that it's been fetched or instructions that has been fetched. So here you can see it's MDR is holding data that's been fetched, holds instructions or data being read from or written to from memory. And then the accumulator will store any results that has been carried out after the execution. So if you go to the next fetch stage, the program counter is pointing to the next instruction. Memory address register will then hold that address, pointing towards that address, and then MDR this time is holding instructions that it has fetched from memory. CPU runs certain amount of times a second. So for example, 1 gigahertz is 1 billion instructions a second. And as you can see, once 1 gigahertz, 1 core, no cache is 1 billion instructions per second. If you increase the core, that could double the performance of the CPU, 2 billion cycles per second. But you have to make sure the software is optimized to run both cores and can run simultaneous tasks. Some programs are not designed to use multiple cores. The more cores you have, the faster. So 4 cores, 4 billion instructions. And if it was 2 gigahertz CPU, 2 times 4, 8 billion instructions. Now the final piece here is cache. Cache is super fast memory inside the CPU, reduces the time needed for waiting for RAM. RAM is slower. So if you have a bit of cache, can you see it's increased to 8.8? Let me reduce the clock speed and the number of cores. So let's do 1 gigahertz clock speed. 1 billion let's do 1 billion instructions per second. And if you add a little bit of RAM, the performance is increased. Now it can do more instructions per second because it doesn't have to fetch from RAM. It can fetch directly from CPU, which is much faster. Increase it to 4 megabytes of cache, 1.4 billion, 16 megabytes of cache. Now you can do more. So the more cache, the faster the CPU. Okay, so some other components of the CPU. Control unit, which is not a register. It coordinates the fetch-decode-execute cycle. It decodes instructions and sends control signals to synchronize all the components. It's like the manager of the CPU. It controls how the fetch-decode-execute works, stops and starts, sends control signals, etc. The arithmetic logic unit performs the calculations, performs arithmetic, addition, subtraction, and logical and or not operations on the data. So it does all the calculations. We've covered cache, covered program counter, stores the memory address register of the next instruction. Memory address register holds the address of memory location being read or written to. Memory data register holds instructions or data that has been fetched from or is waiting to be written to. Accumulator stores the results of the most recent ALU calculation. So stores results. Okay, here's some practice exam questions that students sometimes get wrong. So Alicia is upgrading a CPU from 2.4 gigahertz to 3.8 gigahertz. Explain how this upgrade will affect her computer performance when video editing. So let's look at a student's answer here. Alicia will find that her computer is much faster. It will be able to load the video editing software quicker, so she can do her work better. Let's mark it. Now, this student achieved 0 marks. Uses vague language, faster and quicker. No mention of the fetch-decode-execute cycle, instructions or timeframes. Quicker, better. They're just too vague. We get in the mark scheme sometimes TF, too vague, TV, too vague answer, and achieving no marks. Let's look at a more better answer with the technical terminology you should be using. A higher clock speed means the CPU can perform more fetch, decode, execute cycles per second. Yeah, so it's the time frame there. This means more instructions are processed in the same amount of time frame again, allows the video software to render Alicia's work more quickly, or view Alicia's work more quickly. So correctly identified the marks FDE cycle, more instruction process, and applies video software context. Okay, so you need to use more technical vocabulary. You make sure it's relevant to the question. Let's look at another question. Identify two registers used in the von Neumann architecture and explain their specific role during the fetch execute cycle. Let's look at another. The MAR and MDR. The MAR stores addresses and the MDR stores data. They both help move things around during the cycle. 1 mark for identifying the MAR and MDR, or 2 marks, 1 mark each. And then the MAR stores addresses, the MDR stores data, but fails to explain the specific role during the cycle. E.g., MAR sends data address to RAM, MDR receives the instructions. Perfect student answer. The memory address register, let's mark it. The memory address register identified, okay, correctly identified, holds the address the next instruction data to be fetched from memory. The memory data register then receives the actual instructions or data that is transferred from memory address. Much more better answer, technical terminology used to gain full marks. Embedded systems. A smart microwave uses an embedded system. Define what an embedded system is and give one benefit of using one in a microwave. 3 marks. So this student got 1 mark. Embedded system is a small computer. Yeah, correctly identified that's inside something else like a microwave, but the benefit is too general. The examiner wants specific purpose and definition. Let's look at a better answer. An embedded system is a dedicated computer system built into a larger device. That is a textbook answer there. Designed for a single specific purpose. A benefit for a microwave is that it increases reliability as there is no unnecessary complex software to crash. Defines as dedicated built-in, 1 mark. Mentions single specific purpose, 1 mark. And provides a valid benefit like reliability or cheaper to the manufacturer. Let's look at another question. State the purpose of the control unit and the arithmetic logic unit, 2 marks. This student achieves 0 marks. The CU controls the computer, very vague. What does that mean? LU does the maths. They work together to make the CPU work. Controls the computer, does the math are too vague. Use technical terms instead. So let's look at a technical term answer. The control unit coordinates the activity of the CPU or sends out control signals and manages the Fetch-Decode-Execute cycle. The arithmetic logic unit performs arithmetic calculation and logical operations like and or not. So these are perfect answers for that question. So you need to give technical definitions. Too vague is what makes students lose marks. Let's have a look. A computer has a quad-core CPU. Explain why doubling the number of cores, which we've discussed earlier, to 4 does not always double its performance because the computer gets too hot. While the thermal throttling is a thing, the primary for J277 software optimization is the main thing. If it gets too many cores running at once, so it has slowed down to protect itself. Too vague, not good enough. Doubling core doesn't double perform because software must be specifically designed or optimized to use multiple cores simultaneously. Some software are not, so it's not always the case. Additionally, there is overhead requirements to coordinate the task. The CPU needs to now manage 2 cores and the software needs to manage 2 cores, so there will be a slight drop in performance. It won't be exactly double the performance. Okay, so these are the type of questions and answers you need to watch out for this topic. I'll see you in the next video.